In this chapter, we will be studying topics in trigonometry. In this lesson, we'll be looking at applications of trigonometry.
Okay, hey everybody. So what we're going to do in this lesson here is we're going to take a look at applications of some of the trig that we've been doing in the last couple of lessons here. But in this case here, what we're going to do here is we're going to run into word problems here where you're not told right off the bat whether this is a sine law problem or a cosine law problem. You got to figure that out. Now additionally, things you need to remember. You need to remember that all the angles in a triangle add up to 180 degrees. You should be in degree mode, okay? Sometimes people are doing the totally correct thing, but because their calculator's in the wrong mode, their numbers are coming out really, really weird. Remember that the longest side is across from the largest angle of the triangle and the smallest side is across from the smallest angle. Okay? If you think about that, it actually makes a lot of sense. And solving a triangle means you're going to find all of the sides and all of the angles so that you know basically everything there is to know about that triangle. And then right here, here's what the sine law looks like and here's what the cosine law looks like. Okay? So those are our tools. Let's just jump in. Let's start looking at some application problems. Okay, so for this first problem, it says, from the top of a tree, the distances to the two peaks of two mountains are 64 kilometers and 97 kilometers as shown. If the distance between the two peaks is 127 kilometers, find the angle between the two surveying lines. Okay, so we're looking for this angle right here at the tree. Okay, actually here, let me zoom in a little. Whoops, wrong way. Let me zoom in a little bit. So here's the scenario that we're looking at. Here's our triangle. Okay, so now I'm going to label this just to make life a little bit easier. So this is going to be A, B, C, which means this is little a, this is going to be little c, and this will be little b. Okay, now I need this angle. What am I going to use? Well, it's clearly not a right angle triangle, so I can't use just your regular old sine, cos, and tan, your primary trig function. It's got to be something a little bit better. And because I don't have an angle and the side opposite it, I can't use the sine law. So this is definitely a cosine law problem. Okay, so now let's move over here. I'm looking for angle A, so it's going to be the cosine of A will equal, and I remember that this is b squared plus c squared minus a squared all over 2bc. And so now I'm just going to plug in the numbers that I'm seeing here. So the cosine of A is going to equal b, 97 squared, plus c, 64 squared, minus 127 squared, there's my A, all over 2 times 97 times 64. Whoops, ran off the screen there. So here we go. Let's enter that in. So in parentheses here, 97 squared plus 64 squared minus 127 squared divided by bracket 2 times 97 times 64. Okay. So, and remember the parentheses are there so that the calculator knows to do this part and this part first and then do the division. And when I do that, I get negative 0.2113 and so on and so forth. So I'm just going to write that out. Cosine of A was negative 0.21134, and that goes on and on forever. So the angle A will be the inverse cosine of, and please don't forget the negative there. It's there for a reason. Okay, it means something there. If you get rid of that, you're doing some extra math there that's not being asked for or not required. So leave it in. So negative 0.21134 ... forever. And now I go to my calculator, and it'll be the inverse cosine, second cosine of that answer. I get 102 degrees. Okay, so my angle A here is 102 degrees. That's all you got to do. But you do got to figure out what law it is that you're applying when you go from question to question. And that can sometimes be the hard part. All right, here's our next question. A 20-meter tall tree makes an angle of 12 degrees with the vertical. To prevent the tree from falling over anymore, a 35-meter rope is attached to the top of the tree and is pegged to the ground some distance away. Find the angle that the rope makes with the ground. Okay, well, we need to draw this. Okay, well, first of all, we've got this 20-meter tall tree at an angle of 12 degrees with the vertical. Okay, well, here's the ground. Let's do it like that. Here's the vertical. And so here's our tree right here at 20 meters. Now, and this is going to be 12 degrees right there. Okay, so here, let me zoom in here. That's what I'm seeing here, 12 degrees. Now, I guess to keep the tree from falling over this way any further, we're going to attach the rope from here. We're going to attach it over here to the ground. This is going to be 35 meters. And so the question is, what's this angle right here? So now let's label this A, B, C. I know that this is going to be equal to little a. I know this will be equal to little c, this 35. And I don't know what little b is, and that's okay. Now, I do, however, know one other thing. I know that angle C is going to be what? Just think about that for a second. I know that this angle is 12, but I also know that the vertical makes a 90-degree angle here, so altogether that's going to be 102 degrees. So I know angle C. And I want to figure out this angle here, A. Well, what have I got? Okay, I've got these two sides in this angle, but this angle is opposite this side. Oh, right there. That's a sine law issue. Oops, that's a sine law problem. So I know, okay, I'm going to set this up. I have got little c over sine of the angle C. I'm looking for angle A, so I'm going to make this little a over the sine of angle A. And then I would cross multiply, so c times the sine of A will equal A times the sine of C. And so the sine of A will equal A sine C over side C. So now that I've got an expression for that, now I'll plug in the pieces here. So my sine of A, whoops, you can't see that, sine of A is going to equal my side A, 20, sine of 102 degrees, all over 35. Okay, so let's figure out what that is. So 20 sine of 102 divided by 35. Okay, so 0.5589. So the sine of A is going to be 0.5589, and it's going to go on and on. I'm going to use the whole decimal here. So angle A will be the inverse sine of 0.5589. I go to my calculator. I've already got that number in there, so second sine of that answer, and rounded to the nearest degree, that's going to be 34 degrees. So that angle would be 34 degrees. Okay, let's take a look at this next one. It says, Grace and Ariane are standing apart on a straight road. They observe a hot air balloon directly between them, 1,432 feet above the ground. The angle of elevation from Grace is 85 degrees. The angle of elevation from Ariane is 81 degrees. Draw the diagram to illustrate the situation and find the distance between Grace and Ariane to the nearest foot. Oh, okay. So here we go. Let's put them along this road here. Okay, let's say this is Grace, this is Ariane. And actually, as soon as I looked at that, I feel bad that I did it that way. I really, if I'd been more true to what I would normally do with this, I would have put those in alphabetic order. Anyway, that's okay. It doesn't matter. So now we're going to put the hot air balloon up here. Here we go. Okay, we know that that is 1432 up. Okay, feet up. And then Grace is looking at it, and Ariane's looking at it. They are not. It's not halfway in between. Sometimes people make that as their kind of their default setting there. The angle of elevation from Grace is 85. Now that again means from the horizontal up. So this is 85 degrees. We know that's going to be straight up, so along the perpendicular. And from Ariane, it's going to be 81 degrees. Okay, so now in this case here, this isn't a sine law or a cosine law problem. Specifically, this is a little bit easier than that because I do have two right angle triangles together. And in fact, what I'm going to do here is I'm going to call this distance here x, and we'll call this distance here y, because what I'm really looking for here is the sum of those two. So I'm going to break this up and just look at the two different triangles here. So in this triangle with Grace, here's my angle. The 1432 is opposite, and I'm looking for the adjacent. Well, that's tangent. So the tangent of 85 degrees is going to equal 1432 over x. And if I want to get what x is, I'm going to multiply up x times the tangent of 85 degrees will equal 1432. And so I can tell you that x will equal, when I divide by the tangent of 85, because I got to get the x by itself, it'll be 1432 over the tangent of 85. Now at this point here, if I wanted to figure out what that number is, I would go to my calculator. But I'm okay with that right now, because I know that I can do it. I already know exactly what I got to do to finish that part of the question off. So I'm just going to go to the next triangle. I'm going to go to this one. And you know what? It's basically, in some ways, a mirror image, except that the angle's a little bit different. It's still going to be tangent because I'm still looking for the adjacent, and I've got the opposite. So it's going to be the tangent of 81 degrees will equal 32 over my y. I will cross multiply. So y times the tangent of 81 degrees is going to equal 1432. So y is going to equal 1432 over the tangent of 81 degrees. And again, this is what I'm going to need to do to get that numeric value. So I'm going to stop right there. Now, I'm looking for the total distance between them. I want the total, and so I know that's going to be x plus y. Well, I know what I needed to do to get x. I needed to do 1432 divided by the tangent of 85. And then I needed to add to that 1432 divided by the tangent of 81. Well, now I'm going to go to my calculator. I'm going to do that whole thing in just one step. I'm not going to break it up into pieces where I might make mistakes with rounding or I might miswrite something or whatever. I'm just going to do this all in one step. So 1432 divided by the tangent of 85, and now notice, look, when I press tangent, it opens up a set of parentheses. I want to close those so that the calculator knows that that's it. That's the angle, done. Then I'm going to add to that 1432 divided by the tangent of 81, and again I'm going to close that off here. And that should be it. When I press enter, that should be the distance between them. And we wanted the answer to the nearest foot, and there it is, 352 feet. So approximately 352 feet. All right, let's take a look at this next question. To calculate the width of a river, the following measurements were made by a surveyor. Find the width of the river the nearest tenth. Okay, here, let's zoom in on that. So what happened here is you have a surveyor standing right here, and they mark off a point kind of visually on the other side of the river. They got that the angle from along the river to that point was 74 degrees, and they walked 250 meters to here, and then looked back at the same spot and saw that that was 60, and they want to know what the width of the river is. This is a classic problem. This one shows up a lot. Okay, so it's good that we're looking at it here. Now, this is, and when you look at this, I am seeing two right-angle triangles. So you might be tempted to think of this as just a basic trig problem, like going back to SOHCAHTOA. But actually it's not. And the reason it's not is because the distance that I'm given here is the sum of those two. Okay, those two sides right there, those two adjacent sides. Which means in this right-angle triangle, I actually only know that angle and this angle. I don't know anything else. I don't know what this side is. I know it's not bigger than 250, but I don't know what it is. Same thing with this triangle. I know that this angle is 60. I know that this angle is 90, but that's it. That's all I know. It's not, do not take the 250 and just divide it into two, make it 125 each, because that's not true. This is not, the width of the river, this line right here, is not halfway in between those two, and I know that because this isn't, these two angles are not the same. If they were the same, then this would be an isosceles triangle, and yeah, I could think of those as being cut evenly, but they're not. So this isn't actually a SOHCAHTOA problem. This has got to be the sine law or the cosine law. So I'm going to label this A, okay, let's make this B, C. And what do I know? Well, I know little b, okay, little b is equal to 250. I know angle A, I know angle C. Actually, having said that, I do know angle B though, okay? Because I know that the sum of the angles in a triangle has to be 180, so I'm just going to take 74 and 60 and subtract that from 180, and it turns out B is going to be 46. So I do know that. And that actually means that I know an angle and the side opposite. Okay, I know that angle, that entire angle, and the 250. Okay, that's good. So that means I can find either little c or I can find little a. Now that's not exactly what I'm looking for, but at least that's a start. I'm moving forward. Okay, so let's zoom out a little bit here. Let's use the sine law. Let's find a. Let's find little a here. So I know b over the sine of angle b will be equal to little a over the sine of angle a. This will be 250 over the sine of 46 degrees will equal a, don't know what that is, over the sine of 74. But the work here is easier. When you're using the sine law to find a side, it's actually a little bit easier because there's one less step. I don't need to do the inverse trig of anything here. All I've got to do, okay, pull up the calculator here and make that 250 sine of 74, closing the brackets to make sure I'm done with the angle, divided by the sine of 46. Okay, and I'm getting 334.1. Okay, so 334.1, what is it, meters? Meters. Approximately is equal to A. Now, I'm going to need that calculation, that number here in a few minutes, so I'm just going to leave that in there. Okay, now if I go back to this triangle, well, now I know what A is. A was 334.1. So let's zoom in again. Well, now I do have some information about this right angle triangle. Now I know this angle, I know this is 90, and I know that the hypotenuse is 334.1. Okay, now I can use just basic trigonometry. I'm interested in this angle. I want the opposite. I have the hypotenuse. That's sine. Okay, so the sine of angle C is going to equal the width, W, over the hypotenuse. In this case, that's going to be little a here. So this is going to be the sine of 60 degrees will equal W over 334.1. I will multiply that up to get 334.1. Sine of 60 degrees is equal to the width. Except when I do this, I'm going to leave that number there. In fact, I'm just going to press multiply by because the calculator will immediately know that I mean that. The sine of 60, press enter, and there it is, 289.3. 289.3 meters is approximately equal to the width of the river. It's a good question. Okay, so this last one here that we're going to do, kind of an interesting one. It says, a real estate agent is considering purchasing a piece of triangular property and is waiting for the surveyor's report before closing the deal. If the surveyor submits the following diagram, right there, why would the real estate agent reject the sale? And then the hint here is, what is the angle opposite from the 400-foot side? So we're looking for this one right here to figure out what's going on here. So let's call this A, B, C. And we're looking for angle C here. Now this is clearly not a right angle triangle. I have got, though, an angle and the side opposite it. So that's the sine law. So I know that this is my little a, this is going to be my little c, here's my little b. So I know a over the sine of a, or at least I can determine that ratio. That's going to be 400 over the sine of angle c. Oh, I've already plugged stuff in here. Okay, well, here, I'll do this again here. I was going to put little c there. So let's just make this 370 over the sine of 71 degrees is equal to 400 over the sine of c. All right, now we cross multiply, so 370 sine of c is equal to 400 sine of 71. So the sine of c is going to be 400 sine of 71 degrees over 370. Okay, so now let's figure out what that is. Sine of c is going to equal, let's go to the calculator. So that will be, oops, I got to go back here. 400 sine of 71 divided by 370. Okay, and so we get 1.0221 ... I'm just going to leave that like that. So C is supposed to be the inverse sine of 1.0221. So now we go to our calculator and we get second sine, inverse sine of that answer. Oh, and we get an error. So this is an error here. Oh, and there's the issue right there. See, it's an interesting thing about these trig ratios here, particularly sine and cosine. Tangent's a little different, but sine and cosine can never be numbers bigger than 1 or less than -1. They just can't be. Basically, it's part of the definition here. So this is impossible. Okay, this diagram that this surveyor is giving us just doesn't work at all. Okay, so that's why there's a problem there. That angle doesn't exist. So the surveyor admits to his mistake and revises his drawing. This time the real estate agent refuses to complete the deal until all the property information is supplied. So solve the triangle for the missing information here. Okay, so the surveyor figured out that was supposed to be 61 degrees instead, not 71. So let's relabel it A, B, C. So this will be little a, this will be little c. We don't know b here. Okay, so now we're going to go through and we're going to find everything here that we don't know. So the first thing we're going to do here is we're going to find angle C. Okay, so let's come down here. So I've got little a over the sine of a will equal little c, and I did that right this time, over the sine of angle C. So 370 over the sine of 61 degrees will equal 400 over the sine of angle C, because I don't know what that is. Cross multiply. And then we'll divide. So the sine of C is going to equal 400 sine of 61 degrees over 370. So this time I'm hoping that this isn't a number bigger than 1. But you get the idea that that was fixed here. So 400 sine of 61 divided by 370. Okay, good. That's much better. So my ratio here that I got was 0.9455, and again the decimal goes on. So to get that, I'm going to do the inverse sine of 0.9455 ... Then I go to my calculator. Second sine of that answer, and I get 71 degrees. So C is going to equal 71 degrees. Fantastic. Now, as soon as I know that, well then I know what angle B is going to be, because I know that the three angles have to add up to 180. So I'm just going to subtract 71 and 61 from 180, and that's going to get me that angle B is equal to 48 degrees. So there we go. Now I've got almost everything I need here. I know that that's 48. I know that this is 71. The only thing that I'm missing now is this little side here, B. Okay? And I could basically use whatever I want here, but I'm going to go back to the sine law because that's going to use information that I was given right at the beginning here. So I'm going to set this up as A over the sine of A will equal little b over the sine of angle B. Okay? And so now this is going to be 370 over the sine of 61 will equal B, that's what I'm looking for, over the sine of 48 degrees. And in this case here, to get little b, I just have to multiply up by the sine of 48 here. So this will be 370 sine of 48 degrees over the sine of 61 is going to equal b. And so 370 sine of 48 divided by the sine of 61. Now some here might protest because I'm using 48 here as opposed to like the long decimal that I would have gotten. However, that was accurate to like the thousandth of a, this is going to be close to within a few thousandths of the degree here. That's really not going to make much difference in the overall calculation. So I was pretty confident that when I press enter here and I get 314 314, what is that, 0.4? What is this, meters? Feet. That's going to be close enough to what I need.